Next up we have Graham Clark from Explio with 20 years of experience in management, testing, development as well, who's leading currently on their test approach and quality approach in Explio.
Thanks very much. Get the slides working first. Okay, hi everybody. For those of you who don't know who we are, Explio are the world's largest software quality company. We're active in 25 different regions, 30 different business verticals. Last year we did 1.1 billion in revenue. We've been in Belfast for about 12 years, formerly known as SQS Systems. My role in Explio is as Global Head of Devops Services. But I'm here today to talk about dynamic environments. And I'm going to set that very firmly in the context of DevOps and of continuous testing. And I'm going to talk about where environments come in to our continuous testing pipelines and what sorts of issues and problems we can find with them. I'll then talk a bit about some technologies like infrastructure as code, configuration management and orchestration that we can use to solve some of those problems, and how we can go about testing these dynamic environments. I'm going to ask where you are on the journey towards utilising and bringing these technologies into your organisations, and then I'll wrap up at the end with a few conclusions. So I'll start up with DevOps. A lot of people don't know what DevOps is. Everybody's got a different definition of it, but at Explio we have a very good definition, and it's one that all of our customers buy into. And what we say is DevOps is about minimum effort to get maximum value out, delivering both early and frequently in the market. And for that, there's three areas. It's about making sure you have the right people doing the right job at the right time. And then those right people are able to continuously build products that are fit for purpose. Now, fit for purpose doesn't mean that there's no bugs in the software. That's not really possible. It's about making sure that the software is what our clients are going to pay for and find value in. And the third part, the most important part for me, is to measure and realize the business value of the software we're delivering. We bring all those things together to get a working definition for DevOps. Now, part of this is the continuously building products that are fit for purpose, and for that we need continuous testing. And a lot of the time people associate the continuous testing pipeline with DevOps. Now, we break that into three particular areas. Area number one is what we call early lifecycle static analysis. And this is about when we take our code and we run tools on it, we scan it for code quality, or security issues, we look for commenting or code smells or technical debt. And after we've done that, we then move on to what we call early lifecycle dynamic analysis. And this is where we run things like automation tests, Selenium, automated UI, or automated performance or security tests on the code. And the third stage is where we look at manual tests, which is still an important element. We deploy the software to some sort of UAT server, and the manual testers do exploratory and user acceptance testing. And so three particular areas. Now, to look at what an actual pipeline might look like, and this example is based heavily around Microfocus and AWS technologies. So here in my example, Microfocus Octane is going to drive the entire pipeline, and someone's going to come and check some code into, say, GitHub, for example. And once the code's checked in, Octane kicks things off, and Jenkins comes into play, and it builds the code, and it runs unit tests and static tests with SonarQube or Fortify. And when it's done, they need to take the built application and deploy it to our environments for testing. Now, in this case, the big tool is Microfocus Deployment Automation, or DA, and that's going to orchestrate all of these automated deployments. So first we'll deploy to some environments which potentially could be, say, on AWS, and we'll run some sort of UI tests. So we might use, say, UFT or LeanFT to run tests. We heavily use BDD, so we would use, for example, Karate BDD to do BDD API style tests on the software. Now, when that's done, we'll have to deploy again to another set of environments for our performance testing. If you've done any performance work, you know that you really want to try and have it as close as possible to your production environment, so you get a really good indication of whether or not the thing's going to perform correctly under load. So typically we'll have another set of environments there, and we'll run things like load runner or other types of performance tests on it. And likewise, for security testing, we'll deploy somewhere else. Now I know last year we did a lot of dynamic security testing, and we put it on some servers inside our corporate network, and we used Burp Suite and Web Inspect, and those things started to attack the corporate website for fun, and the IT guys came in and they closed this down like in 5 minutes. So we had to deploy to another completely separate set of environments to do the security testing. And then of course finally they'll deploy it out to production, or maybe just at a UAT environment where the manual testers can get at it. So there's a lot of environments involved. And let's just think about exactly how many environments might be involved. So in that particular pipeline, to go one run through it, we've actually got 5 environments. We've got build and static scanning, we've got dynamic functional testing, security, performance, and manual. So 5 sets of environments per run. And I'm going to run that pipeline whenever I check a piece of code in. Now today with DevOps, what we have is we have a cross-functional team that builds our software. We've got developers, testers, BAs, DBAs, all working together in the same team. Now those guys aren't all writing code, but there are other reasons why we would want to run our testing pipeline. Maybe you change a test, or a data, or a script, and we want to do a complete set of tests every single time. So for our example, let's say we have 10 people in our team, and each one of those people is doing something which causes the whole pipeline to run, okay? Now, how many teams in our company? Now, we deal with all sorts of companies, from small to huge global enterprises, and in an average case, we might have, say, maybe 10 teams working in our company, maybe covering 5 or 6 different product lines. And that would be probably a medium-sized enterprise. So let's assume 10 teams. And let's say that everybody in the team is going to check in code or change a test, say, twice a day. Okay? Just to give an example. So if I take all these numbers together and I multiply them out, I find out that per day, I'm going to need 1,000 environments. How many people here have 1,000 physical servers in their company? No? Nobody? No? Okay. But it's okay because we've got virtual machines, right? We can spin up something on Hyper-V, and that'll do the job. How many virtual machines do you think that you could spin up? And do you have the necessary number of processors and RAM? No, I don't think so. It's still a bit dodgy. But it's okay, because what we could do, right, is we could share environments across multiple test runs. That'll work. That'll allow us to scale up. Well, what happens if one of the tests changes a piece of data, or it changes something on the operating system and it goes stale? That's going to affect the results in the next test run. No, that's not going to work either. And by the way, have you told your operations team that you're going to want 1,000 environment requests every day? The guy will be out the door on day number 1 after trying to manage that load. So we've got a problem. And in infrastructure as code and dynamic environments can start to provide a solution to this. So what is infrastructure as code? And it's basically the process of managing and provisioning networks, servers, environments, load balancers, using machine-readable files, scripts, code, rather than human interaction with the actual sort of physical hardware. So there's a number of different techniques. So some examples here, we normally talk about configuration orchestration. And orchestration is about running the script to provision the actual servers. It spins up the various servers, environments that we need. And some of the technologies you might see in there are things like Terraform, or Vagrant, or CloudFormation. We've also got configuration management, and what that means is after we've spun the servers up, we have to put stuff on there. If you're developing a web app, maybe you need to install Tomcat or IIS, or there's some other configuration required, and we can use tools like Chef, Puppet, or Ansible to try and set that stuff up. But looking for a minute just at the configuration orchestration side, Terraform right now is a very popular tool. And it's really for sort of general infrastructure management. It's very good at spinning up large numbers of servers, complex infrastructure, and making sure they're all connected and they're load balanced and stuff like that. And it's completely technology agnostic. If you're using Azure or AWS, it'll work for you. Vagrant is another technology from HashiCorp, the same people that produce Terraform, but it's really focused on producing environments for software development, and it includes an awful lot of features that Terraform would be lacking, and it can do things like sync network folders or HTTP tunneling or all kinds of other exciting things, and it's designed to work with a much smaller number of VMs for specific, very technical purposes. And also, just quickly call out CloudFormation. It's basically equivalent to Terraform, but it's AWS specific. It has a lot more features than Terraform, but only if you're using Amazon. So you've made that decision, that could be a good place to go for it. Okay, so but how does it actually work? Can't quite see this on screen, but this is a Terraform script. By the way, do call around to our desk at the exhibition centre afterwards and play with some of the stuff and see some of the stuff in action. But so this is a Terraform script. Can't really see it, but if you've done any kind of programming whatsoever, it's fairly familiar. There's like bash or DOS style commands, and you can put in functions which are basically look a bit like JavaScript. So you've done Java or C or C#, the syntax will be very, very familiar. And what it does is it goes and it spins up the various infrastructure, and you can't really see, but there's different blocks. So maybe I'm spinning up a server here, and I'm spinning up a load balancer, I'm opening up some IP addresses and ports. There are different sections within the script that can deal with these things. Now, the exciting thing for me is it's not just servers you can spin up here. AWS in particular has a big catalogue of pre-populated server images. Now, earlier on we were talking about having SonarQube in as part of our pipeline. Well, if I wanted to build that, I would get my infrastructure guy to go and he would provision the server and he would install SonarQube on it for me. Don't need to anymore. I can pick a pre-populated SonarQube image out of the Amazon catalogue, run a bit of script, and spin it up straight away. So it starts the server and I can connect to it via RDP and I can start using SonarQube straight away. That's fantastic. No time necessary to install the software anymore. And this can really facilitate if you've got big back-end applications like Oracle, for example, that can be hard to install. Let's just go and run it, from the catalog. And it's also very, very good for license control. The licenses for software are very expensive these days, and typically you need a lot of them. But with this, well, we can either import our existing licenses, or we can pay a little bit more and spin up an image that has a pre-licensed piece of software on it. And this allows you much tighter control of your spend around licenses. You're only going to pay for it while you're using it, and then you shut it down again. And that also is one of the good things about it. When you're finished with this, you can also run all the necessary cleanup. So when you finish with your environment, perhaps when you run it for a few seconds as part of your testing pipeline, Terraform will go and clone everything up, and it'll delete storage, it'll delete servers, it'll delete data, it'll close down all the IP addresses. And this is really important for a couple of reasons, especially when you think about things like GDPR, which we're all probably sick of hearing about by now. But if you've got personal information, we need to guarantee that it's gone at the end of your tests, and this will make sure it's done. There's a number of different pipelines in Terraform that you can configure. There's ones to spin up, ones to run tests, one to clean everything up, and you get nice reports to show you that everything's been done and has completely been cleaned up. And it's also very good, again, for the license control. You can be sure that you're not paying for the infrastructure whenever it gets brought down again. So again, very tight control of the costs. Now the problem is that that's great. We can spin up all these environments, but surely we still have to go and check that they're working. Right? Okay, we're still going to ask our operations guy to go and manually check every 1,000 environments a day to make sure they're going to do what we need before we run our tests. And that doesn't work either. So thankfully, there's a number of automation technologies that are available to test the environments. And normally we run 3 types of tests. So the first one is static analysis. So this is about, earlier on we talked about SonarQube, so it scans your C# code, for example, to look for code quality issues. Well, we can use SonarQube or TerraScan, also provided by Terraform, to scan our IAC scripts to see if they're okay. Are there any glaring mistakes in there? And that will help us to catch an awful lot of errors straight away. Now, when we've run the script and the environment spins up, we can now run infrastructure tests. Let's just make sure that the right version of IIS or Tomcat's been installed. Let's make sure that the ports are open before we even start running our tests. In some cases, running especially security tests can be very, very slow, and we don't want to have this thing kick off overnight to find that it shuts down 1 hour after we've gone home because the port's not open. So we can run a few sort of infrastructure tests. And finally then, we can also run some end-to-end application tests. Deploy your app, run a few tests to make sure it's working. If you're using like a web app, maybe it connects to a database server, run an end-to-end test that reads and writes data to make sure that the connections are all actually working. And all of this information then can be fed back and dropped into a report, like so using Allure or Extent, or fed back into your project management system in form of bugs, like it'll log tickets, for example, in Micro Focus Octane. And the good news is as well that we can build these things in as part of our continuous testing pipeline. So after Jenkins is finished doing the build, well, it can then launch the IAC script and spin up the environments automatically. It can run all of the smoke tests on the environment, all as part of the dynamic pipeline. So at no point do we ever have to get manually involved unless, of course, there's some source of error. And this is really going to facilitate this constant, continuous, end-to-end automation tests of the system, which really help us to get early to market and provide that level of confidence that the system is working correctly. So what I want to talk about now is the journey towards dynamic environments, about how we use these technologies and adopt them. And what we have found from speaking with our customers is that typically they're on one of these sort of 5 stages towards using this. At stage 0, a lot of people are still dealing with bare servers. You know, they've got loads and loads of physical hardware, which is fine. At stage 1, we're using VMs. VMs have been around a long time. A lot of people are very, very comfortable using them, and you do get a lot of value out of them. We move to stage 2, we're starting to think about migrating stuff out to the cloud. Perhaps servers that are particularly difficult to maintain or are old-fashioned and need to be replaced. It might make sense to move stuff out to AWS, and we have a lot of clients that are really playing with that, seeing how much they can move out to the cloud. It's cheaper, it's easier to maintain. But at stage 3 here, we're now bringing in these sort of dynamic technologies like infrastructure as code. Docker would go in there as well, using containers, and deploying those up to cloud-based servers. But at the very high level, you start to move into serverless technologies using stuff like Azure Functions or AWS Lambda. And with these technologies, we don't care about the server. We just throw the stuff up into the ether and ask Amazon to handle the scale and the management of the application. Now, regardless of where you're at, the most essential part is having visibility and management of your environments. You need to know when it's time to move a server out to the cloud or when to bring these technologies in, especially if you're a large organization with hundreds or thousands of environments at play. You need to see where they're being used and what the operational costs are. So having a utility like Innovate here, for example, which is an environment management tool, to help get that visibility and measurement throughout the process is essential. And that's one good example that we would use on a fairly regular basis and deploy to our clients. So to sort of bring this to a close, what can dynamic environments do for me? Facilitate automated deployment of our entire system. This for me is the big one. With DevOps, we want to automate the deployment of the entire enterprise system. Let's not just focus on one part of it or one app or one website. Let's deploy everything as one piece and run complete end-to-end automation tests. Integration is always the killer in software development. It's where most of the errors come in. So let's automate that. People say to me, well, you say we should automate the deployment of the whole system, but we have this massive Oracle database in the back end. It takes 5 days to spin it up and 3 days to configure it. Let's see you automate that. And you go, okay, well actually there's an AWS image with Oracle pre-populated on it. How about that for a starter? So this can really help facilitate the automated deployment of the entire system. It can help us to standardize our environments. How many times have we seen where our pre-prod and our production environments are completely different? And we introduce so many errors and so much manual effort deploying the different systems. Let's have one script which creates both, potentially with different numbers of processors or memory, but it's the same environment, it's the same configuration, and standardization will reduce time, reduce error, reduce manual effort and cost. And then finally, a big thing as well is cost control. We can see how much we're spending, when, we can put limits on it, we can control our licenses, and especially as we use more and more of these technologies, that becomes more and more important. So that's basically it. Do come and talk to us. We're out there next to the coffee bar. We have a number of technical experts there who can answer a lot better than I can some of the technical questions. Come and have a look at some of the technologies. We've got a few demos. Come and play with the Innovate Environment Visibility and Management tool as well. Think about how you can maybe utilize some of these technologies and where you are on the overall journey towards dynamic environments. And that's me. Thank you very much.